Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 58. This problem tells us that we have a compound with molecular formula of C11H15NO2, which has a benzene ring, and it has two substituents coming off of that ring. One of them being a nitrogen with two methyl groups attached to it, and one of them being, and this bond is on the benzene, and one of them being a carbonyl group, or actually an ester group, which is ethically substituted as well. So it says that given the CNMR spectra, the carbon-13 NMR spectra here, what disubstituted benzene isomer corresponds to these carbon data? Well, let's draw all possible isomers. So we can have ortho, meta, para substituted. So we'll arbitrarily say that this amino group is our reference. So we can have ortho substituted. We can have meta substituted. Or we can have para substituted. So these are the three possibilities. Now let's go over to the carbon-13 NMR spectra to get some information out of it. So we know that we have an aromatic ring, and we know that aromatic carbons absorb or show peaks around 110 to 155 ppm. So if we look at that range, around here to here, we see that we have 1, 2, 3, 4 types of unique carbons. So right off the bat, this is all the information we need off this carbon NMR, because we know obviously that we're going to pick up all the different types of chemically distinct protons. We have 1, 2, 3, 4, 5, 6, 7, 8 types of protons in total, 4 of them being on the aromatic ring. So now let's determine how many different types of carbons we would have on each of these aromatic rings, and whichever one is equals to 4, that's going to be the right isomer for matching this NMR data. So here we have a carbon that's bound to a nitrogen carbon-carbon, so this is type 1. Right next to it, we have a carbon that's attached to a carbon that is bound to an ester bond, another carbon-carbon, so this is obviously different. Then we have a carbon that is bound to carbon-carbon, and it's on right adjacent to this ester, so that's type 3. Then we have a carbon that's now 2 carbons away from this ester and 2 carbons or 3 carbons away from this nitro group, or amino group, sorry, and that's carbon 4. And now we have a carbon 5. Why? Because now this is 3 carbons away from the ester and only 2 carbons away from the amino group. Then we have, lastly, carbon 6, because this is adjacent to the amino group. And the same can be said true for this molecule here. We will have 6 different types of aromatic compound or aromatic carbons. But now what about this molecule here? Well, this molecule here has obviously this carbon here, type 1, is bound to this nitrogen. This carbon here, type 2, bound to this oxygen. But now these 2 carbons are both 1 carbon away from this ester and 2 carbons away from this nitrogen. So these 2 carbons are actually the same. Now what about these 2 here? Well, these 2 carbons are 1 carbon away from this nitrogen and now 2 carbons away from this ester. So they were also going to be the same. So this para-substituted isomer has 4 different types of carbons in the aromatic ring. So we know that right away this is going to be our target compound of interest that represents this carbon-13 NMR spectra, and we know that it's not going to be the meta or ortho substituted because these ones all have 6 different types of carbons, while this one has 4, and this is what's shown in our carbon-13 NMR.